Hello all. Today we are going to see the last topic of this unit, that is application of differential equation. Now we are going to see application related to electrical circuits. So first is the voltage drop across a resistor is proportional. Now if there is any circuit, there must be a potential drop or potential difference, that is nothing but the voltage drop. So voltage drop across a resistance is proportional to the current passing through the resistor. So if ER is the voltage drop across resistance, then it is equal to R multiplied by I, where R is the resistance and I is the current. Then voltage drop across an inductor is denoted by L, so is proportional to the instantaneous time rate of change of the current. So if EL is the voltage drop across the inductor, then it is equal to L multiplied by di by dt. Third is voltage drop across capacitor is proportional to the instantaneous electric charge on the capacitor. Now if EC is the voltage drop across a capacitor, then EC can be denoted as Q by C, where Q is the charge and C is the capacitor. Now main important law of this electrical circuit is Kirchoff's law. So Kirchoff's law is the algebraic sum of all the voltage drops around circuit is equal to the voltage supplied, that is EMF. So sum of all voltage drop is equal to total applied EMF, and this is nothing but the Kirchoff's law. Now what are the units for EMF unit is volt, resistance unit is ohm, inductance unit is Henry, capacitance unit is farad, current unit is ampere, and charge unit is coulomb. Sometimes this Q can be written in the form of small q also. So if we consider LC circuit, then voltage drop across L is L di by dt, a voltage drop across C is Q by C, and by using Kirchoff's law, sum of voltage drops is equal to total applied EMF. If total applied EMF is equal to 0, then it is L di by dt plus Q by C is equal to 0. Then if the circuit is LR circuit, then voltage drop across inductance plus voltage drop across resistance is equal to total applied EMF. So voltage drop across inductance is L di by dt plus voltage drop across resistance is Ri is equal to E. Now if we have LCR circuit, means inductance, capacitance and resistance, then a voltage drop across inductance is L di by dt plus voltage drop across resistance is Ri plus voltage drop across capacitance is Q by C, it is equal to total applied EMF. Now if E is equal to 0, then this equation becomes homogeneous differential equation. So it can be written as L di by dt plus Ri plus Q by C is equal to 0. But if equation is in terms of I and Q both, so we try to convert either that equation in terms of Q or in terms of I. So IE, relation between charge and current is equal to rate of change of charge. So I is equal to dq by dt, or Q can be written as integration over I dt. So this equation number 1 becomes L di by dt. In place of I we substitute dq by dt, so it becomes d2q by dt square plus Ri. I is dq by dt plus Q by C, it is equal to E. Now if we divide this by L, then d2q by dt square plus R by L dq by dt plus Q by LC is equal to E by L. This is a second order differential non-homogeneous differential equation because left and right hand side is present. So second order non-homogeneous differential equation with constant coefficient, because this resistance, inductance, it has a constant value, so with constant coefficient. Now to solve this, we have to consider this R by L as some constant, then 1 upon LC we denote by one constant, which is omega square is equal to 1 by LC, then R by L is equal to K0 suppose we denote, and E by L is equal to E0. So this equation number 2 become d2q by dt square plus k0 into dq by dt plus w square omega square into q is equal to E0. So this is the second order differential equation in terms of charge. You can calculate this differential equation in terms of current also, or after finding out charge you can find out current, that is I is equal to dq by dt. So find out derivative of charge, you will get current. Now we see one example on this. So if we have, question is, an inductor of 0.5 henries is connected in series with a resistor of 6 ohms, a capacitor of 0.02 farad and a generator having alternative voltage given by 24 sin 10t. T is greater than 0 and a switch K. Switch is K. Then first thing is we want to find out, set up a differential equation for the instantaneous charge on the condenser, and second, find the charge and the current at time t if the charge on the capacitor is 0 when the switch K is closed at time t is equal to 0. So we have all the values are given. See here, inductor means L. L value is given as 0.5 Henry. Then resistor is 6 ohm. So R is equal to 6 ohm. Next, capacitor is given as 0.02 farad. So C is equal to 0.02 farad. And applied EMF, that is E, is given, which is 24 sin 10t. Now, what we want to find out, set up a differential equation for the instantaneous charge on the condenser. So just now we have seen differential equation in terms of charge. It is LCR circuit. So for LCR circuit, differential equation is voltage drop across inductance plus voltage drop across resistance plus voltage drop across capacitance is equal to total applied EMF. So L into d2q by dt square plus R into dq by dt plus q by C is equal to E. If we substitute, q is equal to dq by dt is equal to I. dq by dt is equal to I, then we get L d2q by dt square plus R dq by dt plus q by C is equal to E. Now all the values are given. If all values are given, substitute values. So L is equal d2q by dt square plus R by L dq by dt plus q by LC, it is equal to E by L. Now substituting all the values, d2q by dt square plus R by L means 6 by L 0.5 dq by dt plus q by L into C. L is 0.5 and C is 0.02 is equal to E by L. E is 24 sin 10t divided by L, which is 0.5. So if we solve this, it is equal to d2q by dt square plus this is 60 by 5, 0.5. 6 by 0.5 means 60 by 5. So it is equal to 12 dq by dt plus this is 0.5 into 0.02. So this is 6 by 0.5 is 12 dq by dt plus 0.5 multiplied by 0.02 is 0.01 and 1 upon 0.01 is 100 q is equal to 24 by 0.5 means 240 by 5, which is 48 sin 10t. Now we denote d by dt. Let d by dt is equal to d. So it becomes d2q plus 12dq plus 100q is equal to 48 sin 10t. Now taking q common, d square plus 12d plus 100 multiplied by q is equal to 48 sin 10t. Now finding out CF and PI, to get the answer. So d square, find out roots first. Auxiliary equation is m square plus 10m plus m square plus 12m plus 100 is equal to 0. So it is, what are the roots of m square plus 12m plus 100? Roots are, finding our roots, m is equal to minus b plus minus square root of b square, that is 144 minus 4ac divided by 2a. So it is equal to 2, which is m is equal to minus of 12 plus minus square root of 144 minus 400. It is equal to 144 minus 400 divided by 2. So it is equal to minus 12 plus minus square root of 144 minus 400 is minus of 256 divided by 2. So it is minus of 12 plus minus square root of 256 is 16i divided by 2. So m value is equal to minus 6 plus minus 8i. So m is equal to alpha plus minus beta I. Alpha is equal to minus 6 and beta is equal to 8. Now write down CF. CF is equal to e to the power alpha x, that is minus 6 x, but here instead of x, independent variable is t. In bracket c1 cos of beta x plus c2 sin of beta x. Then pi, particular integral, it is equal to 1 upon d square plus 12d plus 100 multiplied by right hand side. Right hand side is our 48 sin 10t. 48 sin 10t. So replace here, sin means trigonometric function. Replace d square by minus of a square, which is minus of a is 10, so minus of 100. Replace d square by minus 100, it is 1 upon minus 100 plus 12d plus 100 multiplied by 48 sin 10t. So minus 100 plus 100 get cancelled. 48 divided by 12 integration of sin of 10t, because remaining is only 1 upon d. So 1 by d is integration. So integration of sin t 10t dt, which is 4 times integration of sin is minus of cos 10t divided by 10. So this is equal to minus cos 10t divided by times 2 by 5. So this is minus of 2 by 5 cos of 10t. This is pi. Now final solution is q. Dependent variable is here. Q is equal to cf plus pi. Cf is e to the power minus 60 in bracket c1 cos of 80 plus c2 sin of 80 minus 2 by 5 times cos of 10t. Now to find out C1 and C2, here condition is given. What is that condition? Condition is find the charge and the current at time t if the charge on the capacitor is 0 when the switch key is closed at time t is equal to 0. So what is the meaning of this? Charge on the capacitor is 0. So at time t is equal to 0, and initially if charge is 0, current is also 0. So given is q is equal to 0 and ti is equal to 0 when t is equal to 0. So I we get when di by dt we find out, dq by dt we find out. So differentiate this equation number 1 with respect to t. dq by dt, and dq by dt value is nothing but I. So it is equal to e to the power minus 60 derivative. Here we have two brackets, so two functions. We use product rule. E to the power minus 60 as it is derivative of c1 cos 80, which is minus of 8c1 sin 80 plus 8c2 cos 80 minus 2 by plus derivative of e to the power minus 60 is minus 6 into e to the power minus 60 multiplied by c1 cos of 80 plus c2 sin of 80 minus 2 by 5 times cos into derivative of cos is minus sign. So plus 2 by 5 times 10 multiplied by sin of 10t. So this is our current I. Now using this equation number 1 and 2 and using this condition Q is equal to 0, I is equal to 0 when T is equal to 0, we find out values of C1 and C2. So first Q is equal to 0 when T is equal to 0. Q is equal to 0 when T is equal to 0. Put in 1. So Q 0, T is equal to 0, e to the power 0 is 1, C1 cos of 0 is 1, sin 0 is 0, minus 2 by 5 times cos 0 is 1. So it is equal to, this implies C1 value is 2 by 5. C1 is equal to 2 by 5. Now next condition is I is equal to 0. Next condition is I is equal to 0 when T is equal to 0. Put in equation number 2. So I is equal to e to the power minus e to the power 0 is 1 minus of 8 sin 0. Sin 0 is 0 plus 8 cos 0 is 1 minus 6 e to the power 0 is 1, C1 cos 0 is 1, sin 0 is 0 plus 20 plus 4 times sin 0 is 0. So this is equal to I is equal to 0. So 0 is equal to, this term is 0, 8c2 minus 6c1. So this implies C2, C1 value already we have find out. So put that value, 8C2 is equal to 6C1. C1 is equal to A. This is C2 is equal to 6. Sorry, this is 6 by 8 C1. C1 value is already we have find out, which is 2 by 5. So which is equal to, this is 4. This is 3 by 10. 3 by 10. So C2, C1 value we got 2 by 5 and C2 value is equal to 3 by 10. C2 is equal to 3 by 10. Now substituting the C1 and C2 value in equation number 1 and 2. So charge Q is given as e to the power minus 60 in bracket C1 is 2 by 5 cos of 80 plus 3 by 10 sine of 80 minus 2 by 5 cos of 10t. So first question is find the charge at time t. So at any time t you can find out charge at t is equal to 1, at t is equal to 2. So this is the charge at time t. Now I is equal to, in I also substitute C1 and C2 value. So I is equal to e to the power minus 60 in bracket minus of 8 C1. C1 is 2 by 5 sine of 80 plus 8 C2 3 by 10 cos of 80 minus minus 6 e to the power minus 60. C1 is 2 by 5 cos of 80 plus C2 is 3 by 10 sine of 80 plus 4 times sine of 10t. So this is the value of I. You can simplify it further by combining these two terms. You will get I is equal to e to the power minus 60 outside. It is minus of 16 by 5 and minus of 18 by 10 times sine 80 plus 24 by 10 minus 12 by 5 into cos of 80 plus 4 times sine 10t. So I is equal to e to the power minus 60. Simplify it further. So this is minus 5 sine 80 and this term get vanished plus 4 sine 10t. So this is the final answer for the current at any time t. Thank you.